Hello and welcome to the Titus Timeout Podcast. I'm Jenny Abney-Civy, and today we're going to talk about underfloor air distribution, often referred to as UFAD, UFAD. Now, I can't possibly cover everything there is to know about underfloor systems in a short video podcast, but I'll touch on the basics in this one. The podcast will be a little longer than usual, and then underfloor air distribution will probably come several part series of podcasts. If you can't wait for the next podcast, ASHRAE also has a newly released design guide called UFAD Guide, Design, Construction, and Operation of Underfloor Air Distribution Systems that you can buy and learn all about UFAD design. So let's start with the basics. Underfloor air distribution systems use the underfloor area of a raised floor system as part of the HVAC system. Underfloor systems originated in Europe, but started gaining popularity in the U.S. about 15 to 20 years ago. Raised floor systems have been around a lot longer than that, but they were primarily used to run cable under computer room floors, and if you were supplying air, it was to cool the computers and equipment, not for personal comfort. So let's start by looking at the components of the floor itself. The raised floor system is made up of pedestals that are mounted to the slab and laid out in a grid pattern with raised floor tiles sitting on top of those. The raised floor tile is a 2x2 tile that's 2 foot by 2 foot, and then on top of that there's carpet, usually 18 by 18 or 2x2 in size. So let's draw a couple more pedestals on this tile. So you can see this is how each individual tile would be laid out. Now in an office space, let's move this out of the way, you would see this throughout the entire floor plate. Draw the concrete slab down here, and up here are the tiles, and then let's draw some pedestals in. So the underfloor air distribution system uses the space between the raised floor and the structural slab as a supply air plenum for the room. Typical heights of the raised floor are between 12 and 18 inches. If you go lower, it's hard to put equipment under the floor. If you go higher, it can add to the height of the building. In a UFAD system, you pressurize the plenum space between the raised floor and the subfloor. Diffusers designed for underfloor systems are used to supply airflow to the space above. We've actually seen some UFAD systems that use VAV boxes and ductwork under the floor, but that's not very common, and we're not going to cover that here. The floor is pressurized to between 0.05 and 0.08 inches, and this pressure is maintained by dampers controlled by pressure taps throughout the floor. Okay, so let's draw a little underfloor system from above. Let's say this is your floor plate and your supply air is coming in here from the side. You can only go so far across the slab when you supply air before it starts to warm up. Originally, people would go up to about 60 feet from the air supply to the last diffuser, but now we see much shorter distances, closer to 30 feet. What you often see are air highways in the plenum. Air highways are basically ductwork run in the plenum that have dampers to control the airflow to the plenum. It might look something like this. So from the damper to the farthest diffuser is now only 30 feet. Air leakage from the plenum is a very important consideration as well. On the room side of the raised floor, the carpet tiles will help seal the plenum, and any leakage will go into the occupied space, so it's not as big an issue. A bigger concern is sealing any wall penetrations in the plenum space so that supply air doesn't leak into the space between the walls, which is a waste of energy. Leakage is an issue that got a lot of press a couple years ago, but it can be handled pretty well with sealing the plenum during construction. One benefit to an underfloor air distribution system is that you only have to cool the occupied space. In a traditional overhead system, the diffusers are on the ceiling. The air from the diffusers has to travel across the ceiling, around the walls, and down into the occupied space. So if we look at that, it looks something like this. Put a diffuser in, draw a little room, and the air is going to roll the room something like this. So what you have is 55-degree air, and it's 150 feet per minute somewhere shortly outside the diffuser. It rolls the room and mixes and becomes 75 degrees and 50 feet per minute in the occupied space. But in an underfloor air distribution system, the supply air is supplied at the floor right into the occupied zone. So you don't have to cool all the way up to the ceiling. You only have to cool the space the occupants are working in. So let's draw that. Draw a room, our raised floor, and these are diffusers. We'll talk more about them in a minute. Putting air into the space. Because you're supplying air directly into the occupied space, you can use warmer air temperatures. Depending on where the project is located, you may have to cool your air down to 55 to dehumidify, but then you would mix it with return air to warm it up some. Essentially, underfloor systems use somewhere between 60 and 65 degrees supply air at the diffusers. Like I said, you only want to cool the occupied zone. There's no reason to pay to cool the ceiling because no one is up there. So what you end up with is a stratified layer that you don't want to break, where warm air is at the top and somewhere in the middle, somewhere between say 4 or 5 feet, there's a stratification layer. UFAD systems use diffusers designed to provide high mixing as close to the diffuser face as possible so that you can get to 75 degrees and 50 feet per minute close to the diffuser. A typical underfloor diffuser is a high induction occupant adjustable swirl diffuser, and it looks something like this. This is our Taffer diffuser. The area around the diffuser that should not be occupied is called the clear zone. For ours, it's 1 foot off center line, forming a circle of 2 feet. Outside the circle should be pretty close to the comfortable range of 75 degrees and 50 feet per minute. You also want the diffuser to have a throw of about 4 to 5 feet so that you don't mix above the stratified layer. If you think about an open plan office, which is a common application for a UFAD system, if you have an 8 by 10 cubicle and you have to sit, say, 10 feet away from a diffuser, then you won't actually be able to be anywhere in your office and have it be comfortable. The air volume on the diffusers are adjusted by rotating the diffuser face, which closes off a damper on the inside. As UFAD systems grew in popularity, we saw a need for more variety of diffusers, and so now they're offered with actuators and control systems as well. These swirl diffusers are used in the core of the building and are about 80 to 100 CFM each, so you'd basically have one for every occupant. Areas of varying load, like the perimeter or conference rooms, are handled a little differently. These areas often have fan-powered boxes or other equipment that helps handle the higher loads. We'll cover this at a future podcast. So why would you want to use a UFAD system? Well, there's several reasons. One is churn. Offices change and people move around a lot. A recent study found that in the U.S. the churn rate, which is the percent of people who move in a year, is 44%. In an overhead system, the diffusers are usually not moved, so if the office is switched around, the diffusers may not be located in the best location afterwards. UFAD systems are flexible. You don't have to decide where the diffuser goes until you put the furniture in, and if the office moves, you just move the floor tile with the diffuser to its new location. Thermal comfort is another benefit to using a UFAD system. Studies have shown that when people have control over their environment, they're more productive. The individually adjustable underfloor diffusers allow occupants to control their airflow in their space. Energy savings is a big reason to use underfloor systems as well. When LEED started gaining popularity, a lot of buildings that wanted LEED certification looked at underfloor systems. But there are a lot of factors that determine whether you'll save energy using a UFAD system. One of the most important ones is climate. If you're in a mild climate, you'll probably see the biggest savings. This is a topic all by itself, and we're out of time, so I'll probably cover this in another podcast as well. So that covers the basics of an underfloor air distribution system. Don't forget to subscribe to our YouTube channel, and thanks for taking the time out with us.